Good afternoon. Today I'm going to discuss using near real-time sensor networks for precision rangeland management. But first I want to acknowledge the many researchers listed here who've contributed to this talk. Managing livestock in extensive rangelands has been a challenging endeavor for ranchers and pastoralists across the world. The rangeland environment is extremely variable in space and time. Forage is tightly coupled with precipitation, which fluctuates widely within and between years. In addition, large tracts of land make monitoring and tracking livestock movement and health difficult and labor-intensive. Much like precision agriculture, where farmers have used technology to better manage crops, recent technological advances have the potential to revolutionize rangeland management by providing ranchers with critical information to better manage their lands. However, much research is needed to learn how to collect, process, and present this data effectively. Much of our unit's research is at the Central Plains Experimental Range, located in the shortgrass prairie of the Western Great Plains. This station has a rich 80-year history of research and is part of the long-term Agroecosystem Research Network. Over the past decade, this station has been a leader in the development of precision rangeland management. We've gone from driving around in pickup trucks, measuring rainfall with a ruler, to having multiple environmental livestock sensor networks reporting data in near real time to researchers and stakeholders. One of our primary stakeholder groups is in the Collaborative Adaptive Rangeland Management Experiment, who adaptively manage cattle on half of our research station. We provide stakeholders with near real-time information on environmental and livestock data to enhance their decision-making and achieving three goals: profitable ranching, increasing bird habitat diversity, and increasing plant diversity. Our ground-based environmental sensor network is embedded in this experimental design. Here, the 10 pastures outlined in red represent traditional rangeland management, with about 20 steers fixed in each pasture. The 10 blue pastures represent the adaptively managed herd, where 200 steer are in one large herd, which are rotated across 10 pastures. We measure rainfall, soil moisture, fluxes of carbon, water, and runoff across these 20 combined pastures. Once our sensors collect the data, each individual station transmits data to our local servers, where it is stored, QA/QC'd, and presented as automated reports and dashboards that we've co-produced with our stakeholders. Working with PDI, we are also streaming our weather station data through the PDI GeoEvent server and presented as an interactive dashboard with data updated hourly for researchers and customers. In addition to our ground-based environmental measurements, our group uses satellite NDVI data to monitor greenness and forage quality through time. Here is greenness data up through last week, which shows that forage is dropping below average for this time of year. The stakeholders are using this information along with maps of rainfall and soil moisture to decide when and where to move the herd next. Along with environmental data, we're using advances in sensor technology to monitor livestock behavior and health. Here we have a cow fitted with a GPS collar to track its location and behavior, a cow Fitbit on its ankle to assess energy use, and an automated walkover scale in the background to track each individual's daily weight gain. Here's an example of the data we can collect with our own in-house designed GPS cattle collar. These show 1-second fixes from a single animal over a 1-month period. This can be combined with remote sensing and ground-based measurements to better understand how cattle are utilizing the landscape. In summary, technological advances are creating a promising future for precision rangeland management. Multiple data streams can be used to link environmental data with livestock behavior and provide decision support tools for adaptive management. These integrated approaches should allow managers to optimize animal performance while also achieving desired environmental outcomes. In our future work with PDI, we're hoping to streamline workflows to improve data collection efficiencies and processing. We also need to mobilize our eddy covariance and micro-watershed data into interactive dashboards, which are not currently available. Finally, we'd like to develop methods to collect GPS collar data remotely from our cattle. Thank you for your time, and I look forward to any questions at the end of the session.